Before we start the next lesson, let's try a few of these Venn diagrams. We're going to call this A, this set B, and this set C. Shade where set A would be. Okay, so that would be here. Let's shade A only. Now A only could be written as A, not B, not C. Where is that going to be? Okay, that's going to be in here. Can you shade this one? What is that? A union B. What's union mean? That means A or B. So we're going to do all of A and all of B. So it's anything in one of those two sets. What is A union B not C? So that's going to be the same thing, except anywhere where there's a C, we can't include it. Okay, so that's going to look something like this. Okay, try this one. What does this mean? So that's the intersection of the three of them. That's where the only place where all three exist. So that's going to be in here. Let's try A intersection B, not C. So here's intersection A and B. But if we go not C, then you're going to have to stop before you get to C. So that's going to be just in this little area. Okay, can you do A and C, not B? Okay, so that's going to be A and C. This is A and C, but if we don't include B, then you're only going to have this part right here. Okay, and what does B and C look like? Okay, that's this one right here, B and C. Okay, let's use it, apply that idea to this. Okay, so take a couple minutes to try it, and then I'll post the answer. All right, here are the answers. Take a look at them, see if they make sense to you. Okay, so for example, number one, how many students like volleyball or swimming but not surfing? So volleyball or swimming but not surfing. Okay, so that's going to be this region right here. Okay, how many students like both volleyball and surfing? Okay, that's going to be volleyball and surfing, so that's all of this. Oh, sorry, like both. That's just this little bit right in here. Okay, so go through that, see if it makes sense to you. I'm going to highlight number 4. There's two ways you could do number 4. How many students do not like both volleyball and surfing? Don't like both volleyball and surfing. So here is volleyball and surfing. And we're trying to find how many don't like that. So one way to do it would be to add up all the other numbers. The other way is you could do add up the total. There's 91 in total, and you could subtract the 35 that do like it both. Okay, so how do you do this one? This one is who doesn't like volleyball and surfing. Okay, so let's do the total takeaway. This is going to be the universal set. Take away the number of V and S. Okay, so that's just one example where I kind of gave you a little bit more information. But you can do that just by looking at the Venn diagram. All right, I'll pause there and we can start the next lesson. Okay, so this is going to be the same kind of question we just did, but none of this information is put into the Venn diagram for you. You're going to have to figure that out. Okay, so let's see if we can kind of pull this apart and try to figure out the things that are not obvious. Okay, first of all, there are 28 children that have a dog cat, or a bird. So all the numbers in here are going to add up to 28. Okay? Then you have the number that own a dog is going to be 13. The number that own a cat is going to be 13. The number that own a bird is going to be 13. If you add those up, that turns out to be 39. So I just told you that this number in here is going to add up to 28. But we have 39 that are the total. So somehow of these 13, there's going to be a whole bunch of stuff that's overlapping in here. We have to figure out what the overlap is. Okay, so let's see if some of the other information is given to us. 4 have only a dog and a cat. So the number that have a dog and a cat, but not a bird, this is 4. Okay, well, let's put this on the Venn diagram right away. Let's go dog, let's go cat, and bird down here. So the number that own a dog and a cat, but not a bird, that's this area right here. Okay, I'm going to put that as 4. Okay, now the number that own a dog and a bird, but not a cat, that's 3. A dog and a bird, but not a cat, that's 3. And the number, the number that own a cat and a bird, but not a dog, that's 2. So that's going to be here, right? This little section right here is dog and cat, sorry, it's cat and bird, but they don't own a dog. Okay, this last thing, no child has 2 of each pet. That doesn't make any difference here. We're not doing that. It says that they have a dog, cat, or bird, not 2 of each. Okay, that's not part of the question. Okay, well, some things don't seem to add up here. It says that there is only 28 that people involved in this set. The universal set, okay, is 28. But somehow we have 39, so we have to figure out this overlap. Okay, now if you think about this area, for example, right here, that's got 2 levels of overlap. People who like dog and a cat. You got to think of this spot right here. This has 3 levels of overlap. Okay, we're counting the number that goes there 3 times. Okay, it overlaps twice. All right, so if we want to figure out what this region is, we're going to do this. We're going to take 39, which is the total, and we're going to subtract the regions that overlap once. And this should give us 28. Okay, so let's try this. 39, take away 4, take away 3, take away 2. Well, we're going to call this x. And remember I said that place is actually counted 3 times, so we're going to take away x twice. That's kind of weird. Why are we doing that? Okay, if you think about those circles, that occurs 3 times. So we're taking away 1 overlap, that's the first x, and we're taking away the second overlap, meaning we're just going to have the 1 number there. Okay, and this is supposed to equal 28. So doing some algebra here, we get 30 take away 2x is 28. And so you get 30 take away 28 equals 2x. So 2 equals 2x, and if I divide both sides, I get x is 2. So let's put that in here. Okay, now if you're not quite sure about that, think back to when we had just 1 overlap. We just wanted to subtract that overlap once. Because this place is going to get overlapped again, that's why we're subtracting x twice. Okay, So now we can figure out, if I know that 13 people have a dog, 13 take away 4, take away 2, take away 3 is 4. So there must be 4 people that have only a dog. I know 13 people have a cat, and I'm going to take away all the overlap parts, leaves me with 5 here. Oh, hang on a second. I made a mistake. I'd say, how come you didn't say anything? But it's because you're over there watching the video. Sorry, that was supposed to be a 1. So now let's go 13 take away 4, take away 1, take away 3. That's 5. And this is 6. And 13 take away 3, take away 1, take away 2 leaves me with 7. Okay, now if I add those all up, it should equal 28. Okay, and I think if you do add them up, it does. Alright, now that you've done that question, try this one. This is basically the identical question, okay, except in this case someone's already solved it. See if you can place all those things where they're supposed to go there. Okay, before I look at Alana's solution, let's see if we can do some of this work. The universal set is going to have 750 people. Okay, students use public transit, so the number of public transit is 370. The number that use cycle and use public transit, okay, so cycle and public transit is 100. 80 students walk and use public transit, that's 80. Walk and cycle is 35. Okay, and then here's a big one. 20 students walk, cycle, and use public transit. They use all of them. Walk, cycle, and public transit. Come on, pen, work. So this one is 20. That's pretty critical. That should go here. Okay, that's nice to be able to figure that out right off the bat. And then it says 440 students use cycle or public transit, so the number of cycle or public transit is 445, and the number that walk or cycle is 265. Okay, let's deal with these first. If we know that 20 do all three and 100 use cycle or public transit, okay, then this region should be 100, meaning I must have 80 here. Okay, does that make sense? Right, the overlap has to be 100. Okay, now that also means walk and public transportation is supposed to be 80. So this section here has to be 80. Well, we've already used 20, so this must be 60 here. And then this one, walk and cycle, has to be 35, meaning this must be 15. Okay? And let's go and look at this one. The number that use public transportation is 370. Well, if I add up 80, 20, and 60, this is 160 that use public transportation, but it says 370 do. So this must be 210, right? 370 take away 160 is 210 that use only public transportation. Okay? Then let's go to this, the number that use cycling or public transportation. Well, we already have for public transportation 210, 80, 20, and 60. And then we also have 15 that are already on the cycling. So what I'm doing is I'm counting this and then all of this. Okay, and you can see that I've got so far 310, 370, this is 385. But we are just told there that 445 use one or the other. So if I take away what I've counted already, this leaves me with 60 more. Okay, let's try this now. 265 students walk or cycle. So that's these two circles combined. Okay, well, what do we have in those two circles already? We have 80, 60, 20, 15, and 60. That's what we've got so far. That's 140, 200, 235. But we were just told that there's 265 in total. This means I must have 30 that walk only. Okay, so let's see how that compares to her solution. So right here, she makes this conclusion. Is this true? 445 students cycle or use public transit, 370 use public transit. That means 75 cycle but do not walk or use public transportation. Well, that's 75, so that's actually true. Okay, and then she says 265 walk or cycle. 75 just cycle. Therefore, 265 take away 75 is 190. This is an error. It doesn't account for the overlaps. Okay, so that's where the first mistake, I guess, comes. She didn't quite know where this 75 should go. She assumed that that 75 was here. It's not. Okay, so then there's a few mistakes here. Instead, let's take a look at our conclusion. How many use green transportation? Well, if we can add 210, 80, 20, 60, 60, 15, and 30. Alright, that gives us 310, 430, 460, 475. Out of the 750. So therefore, what do we have? 275 do not use green transportation. Okay, I'm going to stop there. You can try and do the last example for homework. Okay, I would also like you to do page 192, numbers 2, 4, 6, 7, 9, and 11.